heat capacity and specific heat capacity. But before we quickly go into heat capacity and specific heat capacity, last week we discussed expansion, and we were able to look at calculation under expansivity. We look at consequence and application of expansion. Number one, we look at expansion in buildings and steel bridges. We also talk about expansion in railway lines. As also under the consequence, we also talk about sagging of telegraph wires. We talk about bimetallic strips. And of course, we later talk about expansion in liquid. We look at three good examples: alcohol, mercury, and water. Alcohol and mercury has uniform expansion, but in the case of water, you are told that the expansion in water is not uniform. I usually refer to it as anomalous expansion. We looked at this last week. We later talk about the mode of transferring of heat energy from one point to another in various or different state of matter. The heat is transferred in solid. The process by which heat is transferred in solid from one point to another is called conduction. Why that of fluid? When we say fluid, we mean liquid or gas. The mode of heat transfer in this fluid, the state of matter, is called convection. While the heat energy can also be transferred from one point to another in a vacuum. Vacuum is a place where you don't have solid, no liquid, no gas, yet heat energy gets to us. I also discussed the application. At the end of the class last week, you are told to set 40 objective questions, which must not be quoted from past questions or from any textbook. The submission will be done at the end of the class today. And how the submission will be done is, for the practicals, we are going to group ourselves into 10 groups, 10 in each group. You are going to exchange your question. You retain the marking guy with you. You exchange the question you say with somebody in the group. So he or she is going to do. Where your answer disagree, then when we get to tutorial class, we are going to see the question together. So, but I want to get the name of those of you that exchange the question you are asked to set at the end of the class today. Is that clear?
Yes, sir.
Now today we want to look at heat capacity, specific capacity. Yes.
Heat capacity is the quantity of heat.
Louder please, one class.
Heat capacity is the quantity of heat required to raise the temperature of a substance by 1 Kelvin.
Please clap for her. From Afro to? No, that boy. Yeah, no, the one at the back. Yes.
I said heat capacity, quantity of heat required to raise the temperature of a substance by 1 Kelvin.
That's good. Clap for him too. Can be defined as quantity of heat energy required to change the temperature of a substance by 1 degree Celsius by 1 degree Celsius or 1 Kelvin. Heat capacity can be defined as the quantity of heat required by a substance to change its temperature by 1 degree Celsius or 1 Kelvin. What does that mean to you? How do you explain this? Yeah. For every substance that its temperature needs to be raised, we need to heat the substance. And sometimes last week I told you that heating is to add energy. Heating is what? To add. If I say add, that simply means I ask you to heat. If a substance needs certain amount of energy for its temperature to be raised, certain amount of energy for its temperature to be raised by 1, that quantity of energy required by it is called heat capacity of that substance. As you are now, if your temperature is 16 degrees Celsius, the heat energy I need to supply you so that your temperature will change from 16 to 17. That is the heat capacity of you. This is set. If I take the temperature of this handset, of course, it will be the room temperature. Let us assume that the room temperature is 20 degrees Celsius. Then, what is the quantity of heat I need to supply this foam in order to change its temperature to 21? That quantity of heat is called heat capacity of this foam. Am I communicating?
Yes, sir.
So different substances have different heat capacity. Other name for heat capacity is called thermal capacity. If somebody mentioned thermal capacity, we also it also means heat capacity. Mathematically, heat capacity can be expressed, you can say, mathematically, heat capacity can be expressed as Q, which is the quantity of heat, equals heat capacity then delta theta. This is mathematical expression. Where, of course, where we can say where Q stands for quantity of heat energy. Quantity of heat energy, that's what Q stands for. C, well, like I said last week, whatever you use to donate something must be introduced. One is to use capital letter C to represent heat capacity. Heat capacity or thermal capacity. Then delta theta, you have delta theta here is referred to as change in temperature. Or rise in temperature or increase. You can also refer to it as increase in temperature. Any one you can give to this here, that means theta 2 minus theta 1. Theta 2 here stands for final temperature. Then theta 1 is initial temperature. Initial temperature. Now, just like I said earlier, since delta theta is this, therefore you can say since delta theta equals theta 2 minus theta 1, therefore we can express the quantity of heat energy loss or gain by capital letter C into theta 2 minus theta 1. And that serves as equation 2. If you refer to this one as equation 1. Please let me have another marker that writes very well. Either be increase or decrease. So it is possible. I said earlier that the quantity of heat energy you supply the material to change its temperature by 1. You can also look at it in the other way around, and that is the quantity of heat you take away, you extracted from the material for the temperature of the material to drop by 1. If you are 20 degrees Celsius, quantity of heat you need to take away from the substance so that its temperature will now be 19. That quantity of heat taken away from the material to reduce its temperature by 1 is also known as thermal capacity or heat capacity. Quantity of heat energy required by a substance to change its temperature by 1 degree or Kelvin. Change means it could be rise when you are heating, it could be fall when you are cooling. But quantity of heat needed to increase its temperature by 1 or to decrease its temperature by 1, that quantity of heat is called thermal capacity. It goes beyond cramming. You should understand what it means. Quantity of heat required to raise the temperature of a substance by 1 degree, that is called thermal capacity or heat capacity. Cleared? Yes. The SI unit of heat capacity is joule per Kelvin. Joule per Kelvin. That's the SI unit of heat capacity. Let's go to specific heat capacity. We want to see the second one before we merge it together. Specific heat capacity. What do you understand by specific heat capacity? Having known heat capacity or thermal capacity, can somebody define specific capacity in the class?
Specific heat capacity of the substance is the quantity of heat required to raise the unit mass of the substance by 1 degree Celsius or 1 Kelvin.
Please clap for him. AGGS, can you repeat what they have just said?
Quantity of heat required to change the temperature of the substance by 1 degree Celsius.
By your definition, specific capacity and heat capacity are the same. Okay, please clap for her too, but that is not exactly what she said. Now, please, specific, the word specific or specify has to do with you measure the certain mass of a substance. You specify. If somebody outside says students, or when you are going in your school, a teacher just shout, students. How many of you will answer students? All of you. It does not belong to anyone. Somebody just says, students. Everybody heard, but nobody will want to answer. What's the general name? Heat capacity is general. It's like general now. Substance needs to be mentioned. In what we define here, we said a substance. Whether the whole world, whether small quantity, it wasn't specified in that definition. So there is a need for us to know the quantity of the substance And that's why a unit mass is just going to be added. We need to change this one. Instead of saying a substance, we now put the mass of the substance there. That's where you can quickly learn the two definitions together. Here there is nothing like mass here. We just say a substance. But to now define specific, you want to specify. That's why we say specific heat capacity, not general heat capacity. Specify. So when the word specific is now added, then mass must be mentioned. And that is why we now change the specific capacity will now be defined as, please look at it, specific capacity will now be defined as quantity of heat energy required by a unit mass, of a substance to change its temperature by 1 degree Celsius. Every other thing remains the same, except that you mention the mass. And the mass is a unit mass. Is that clear?
Yes, sir.
You know, I was saying yourself earlier, I made mention of my phone and some other objects. But when you want to demonstrate specific, you have to measure a unit mass. And what is a unit mass? 1 kilogram. So when you say this pen, I measure it, I mean the marker. If the mass of the marker I'm holding is 1 kilogram, then I need to determine its temperature. What is the quantity of heat I need to supply it for its temperature to change by 1? Either to increase by 1, or the quantity of heat I will take away from it so that its temperature will drop by 1. That quantity of heat will be called specific because the mass is 1 kilogram. Because you are considering the mass now. That's why we say, now to now define specific heat capacity, we have specific heat capacity can be defined as the quantity of heat energy required by a unit mass. Please, a unit mass is 1 kilogram. You may not put that, but if you put in bracket, no problem. A unit mass of a substance to change its temperature by 1 degree Celsius or 1 Kelvin. If you look at it critically, the only thing that is added is this. If you remove that, it becomes thermal capacity. If you remove that, it becomes thermal capacity. You can now say dot mathematically specific heat capacity can be expressed as Q equals MC delta theta. Please take note. MC delta theta. Where, of course, you can mention where Q stands for quantity of heat energy. Quantity of heat energy. Then M stands for mass. Sorry, Costa. Advanced heating. Then, of course, delta theta is change in temperature. Or, as said, you can also use rise in temperature. To use rise, you can be rise or fall, depending on what you are doing. I've explained that to you, you should understand. If I say increase, it could be increase or decrease in temperature, which can also be expressed as theta 2 minus theta 1, as shown in heat capacity. The only difference between specific heat capacity and thermal capacity is the mass. The SI unit of specific capacity, now we can say the SI unit of specific heat capacity is joule per kilogram per Kelvin. Joules per kilogram per Kelvin. Please take note of all this. Joule per kilogram per Kelvin. Do you know that specific capacity is a property of substance? Specific capacity is a property of substance. What do I mean by specific capacity is a property of substance? Anybody? Your number belongs to somebody. But if I mention, give me your name. Ayo. If I say Ayomide, how many people will answer Ayomide? How many of you are Ayomide in the class? Raise up your hand. Ayoade. So it means your name is your own property. I can distinguish from one student to the other. If I say differentiate between this and this. Number one thing you can say, this fellow is called this. Why this is called this? So specific capacity can be used to differentiate one substance from the other. You can differentiate. If I hold a bottle and I say specific capacity of a given substance, and I know that of water, specific capacity of water, I hold a bottle, a clean bottle, and I just tell somebody that is not deciding that I have an acid whose specific capacity is 4,200 joules per kilogram per Kelvin, and I want to perform miracle. I want to drink that acid. Once I call this acid and I give you the specific capacity of that, some of you may be shaking because it's an acid. But anybody that knows what you are talking about will know that water, specific capacity of water is 4,200 joules. It's as good as saying, I want to drink water. Because no any other liquid will have the same density with water. Distinguish a substance from another substance. Different liquid. What is the specific capacity of mercury? You find out that just as you have density of liquid are different. So we can use density to differentiate water from mercury. Specific capacity of this is not the same thing with specific capacity of alcohol and so many others. And that's why we said it is a property of the substance. Now, having known that, we know heat capacity, we know specific heat capacity, relationship between the two of them, before we now give you heat, what you need to know to solve questions under this aspect. Now, relationship between specific heat capacity and thermal capacity. What is the relationship between the two quantities, physical quantity? So we put it as What's all about? The relationship between the two of them. What's the relationship between the two of them? The relationship between specific capacity and heat capacity is shown in the expression below. C, okay, let me say specific heat capacity, small letter C, equals heat capacity, capital letter C, all over mass M. In other words, C equals this all over M. That is the relationship between the two of them. This is mass, this is thermal capacity, and this is specific capacity. So, it is heat capacity divided by the mass that will give you the relationship between the two of them. That means we can turn one to the other, provided the mass is given. The following must be noted. We are going into calculation gradually. The following must be noted. Theta. Since change in temperature can be expressed as theta 2 minus theta 1, therefore we can also express this as mc into theta 2 minus theta 1. And we call this equation 2, where of course Q still retains its usual meaning, which is quantity of heat energy. Then we have M equals mass of the substance. Then C, small letter C, is specific heat capacity. Specific capacity. Of course, theta 2 stands for final temperature. Final temperature. Theta 1 stands for initial temperature. Initial temperature. Now, from the two of them, it means heat lost or gain by a substance can be determined by using, let's put it together. So it implies that heat lost or gain by a substance. Heat loss or gain by a substance can be determined by using either Q equals C delta theta the second one is Q equals C delta theta minus this, or by using Q equals MC delta theta slant Q equals MC into theta 2 minus theta 1. Heat lost or gain by a substance can be determined by using Q equals C delta theta, or Q equals C FC theta. The first one is used when thermal capacity is given and the mass is not known. That's where we can use that to determine heat loss or gain. But second one will be used when mass is given, specific capacity is known. Then we use the second one. Any substance at all, including yourself, including any materials around you, you want to determine heat loss or gain by that substance. This expression will be used. But heater has its own way. Of course, heater will always lose heat. Law by heater. Heat law by heater can be determined by using that's Q equals PT, equation 1. That is power times time. We can also say Q equals IVT. That's another equation for heater. We can also say Q equals I square RT. That's another expression for heater. Then we can say Q equals V squared over RT. That's another expression for heater. So heat loss by heater can be determined by using any of the following expressions. But heat loss by a substance or gain by a substance can be determined by this. If thermal capacity is given, we use this. If specific capacity is known, we use this. Any of this will give us heat loss or gain by any substance. But heat loss by heater, one of these expressions will now solve it. You are going to see it hopefully next class. I want to give you the following hint, and I want you to digest it before next class. It's going to help us a lot. 1. Please note the following. Take note of the following. One. Heat energy is conserved. Number one thing you need to know is that the energy is what? Conserved. What does that mean? It means heat loss by a substance will be gained by another substance. You have that at the back of your mind. Heat loss by a substance can be gained by one or two other substances. Or heat gain by a substance must come from, just like the money. You can't destroy it. If you want to know, when you are going to draw 1,000, you lose 1,000, somebody will find it. So, and that is it. So, heat energy is not lost. I mean, you cannot, it's conserved. What somebody lost, some substance loses while some gain. You have that at the back of your mind. 2. Whatever happened to the content, the same will happen to the container. Do you understand what that means? Content are things inside a container. Whatever happened to the content, the same will happen to the container. What do I mean? If the content loses, container will also loses it. Happen to the content, the same will happen to the container. Take note of that. Next, when substance is losing heat, its temperature falls or decreases. When a substance loses heat, its temperature drop or fall or decrease. When you are losing, your temperature will be decreasing. And opposite of that, when you are gaining, what happens to your temperature? Temperature will rise. So every substance that is losing, its temperature will be dropping. There are substances that is gaining, its temperature will be rising. Please take note, it will help us in calculation. These are technical things you need to have at the back of your mind before you can solve question under this correctly. When you remove sander from your, okay, let me say iron, pressing iron. You plug your iron and your hands or your leg suddenly touch the iron. How do you feel? Hot. You remove that part sharply from the iron. Why? If you want to talk, I want somebody who wants to talk. Why? Why do you feel the pain when your body suddenly or accidentally touches surface of the iron, hot iron? Why do you remove the hands or your leg or whatever part of the body that touches it? Yes? Because it has been transferred into the body from. Okay, clap for him. The reason is not far-fetched. The reason is simply because your temperature is lower than the iron, and the iron is very hot. Heat energy suddenly rush into your body. That's why it's painful. The heat energy from the iron flow into your body. The reverse is when you hold the ice block. When you hold it, suddenly you can easily, feel the pains too. What happens in that case? Heat energy rush out of your body to the iron because your temperature is hotter than the temperature of ice block. So if heat energy rush out of you, suddenly you feel the pain. If heat energy run into your body, suddenly you will equally feel the pain. What am I saying? It flow from high temperature to low temperature. When two contents are mixed together, like water, that's where we are going to start class next class. Water and oil. If water is at 80 and oil is at 20, you now mix the two of them together. Water is at 80 degrees Celsius, oil is at 20. Which of the two is hotter? Water that has 80 degrees Celsius is higher than oil that has 20 degrees Celsius. Heat energy will flow from hot water into the oil. And of course, the two of them are liquid. The two has to be kept in a container. Oil is inside a container. If you now pour water into that, remember the container of water is not dropped. You pour hot water out of the container and keep the container elsewhere. So it means what are together now are water, oil, and container. Are we okay? Yes. Now, when water is now added to oil, definitely I have said something that must be kept in mind. Go and read that and digest it before next class. The oil will be gaining heat from water. And oil is the content now. And you are just told that whatever happened to the content, the same will happen to the container. So it means as oil gain heat from the water that is dropped into it, the same with the container of oil will do. That means the container of oil too will equally gain heat energy. That means the two of them gain energy from water. Water is the only one losing. To what? To oil and its container. Why do we talk about the container of water? Why did we not talk about the container of water? Because the water is poured out into the oil. It isn't that you drop the hot water and its container into the oil. If it were to be drop water and its container into the oil, then you are going to consider the heat loss by the container and that of water to heat gain by oil and its container. But the instruction is if the water is poured into that. So bear it in mind. We are going to make use of the following tips I give to you above in solving calculation. Lastly, you must know that one substance may lose to 2, 2 may lose to 1, and 1 may lose to 1. Every question that will come to your way under heat capacity is either 1 lose to 2, or 2 lose to 1, or 1 lose to 1. So you should be able to identify in every question given to you which one has the higher temperature, which one has high temperature, which one has low temperature. Those ones that have low temperature will be the one gaining. The one that have high temperature will be the one losing. So that's where we are going to take it up next class. Today we look at heat capacity, and we said heat capacity is the quantity of heat required by a substance to change its temperature by 1 degree Celsius. And we said the SI unit of heat capacity is joule per Kelvin. Heat capacity is also known as thermal capacity. And specific capacity today we know is the quantity of heat required by a unit mass of a substance to change its temperature by 1 degree Celsius. Our relationship that of heat capacity is just to define heat capacity by the mass. And you are also told that to determine the heat loss or heat gain by a substance, we use this expression, this or this. But for heat capacity, these are the expressions to determine heat loss by the heater. God bless you.